So how many of you are already here joining? So I can see Let's Us Repair. Hi, how are you, Gear? Are you alright? And I have also Chris F. I hope you are doing well. Yeah, I look down because I have my phone where I can chat I can read the chat over there. So let's change the and going further where we left. Alright. So I left to where I need to solder the mains, and I need to pass the live to the switch. Neutral, we're gonna go to the fuse, and it was a discussion about this fuse that someone saying that can heat up and melt. In that one there is no any issue because there is no any source of heat over here to melt. In a comment someone say that it's a bit hazard, like safety, because when you open you have the exposed thingy, but I presume that no one is going to change a fuse with the device, plug it on the mains, right? So you unplug first and then you change a fuse. That's what I know. So because also today I work out to find a different one, I check on all my stock around here, I don't find nothing else, so I'm gonna leave with this one. So I'm gonna use the same one. So we are going to wait to join more people before start soldering. What do you think, guys? Hmm? And if you say something, shall I start or shall I wait? Hmm? So what do you reckon, guys? So what did you say? Shall I start? Well, let's start. So this time I'm gonna use my T245 soldering iron. Actually my soldering station, which is the YCS. And I'm going to do a few soldering, so if anyone join later, I'm gonna explain what I did so far. Right, I'm gonna need now also my hot air station. So let me make a space for the hot air station in this corner. Let's thin a bit this wire as well. Alright, so now is the time to see if it's working actually. So, but first let me find some fuses. Let's see if I have in this box. And here we go, my box with fuses. So we need to find one of let's start with 1 amp, and then I'm gonna measure how many milliamp I need, and then we're gonna start from there to add the right one in. Yeah, all of them mixed around here. Let's have a look this one, what it says. F.5. It's very hard to see the writing on these ones. Find one of 1 amp first, and then to go from there. I know my camera and what is focusing right now. All right. It doesn't say how many are in that. I think I'm gonna need a F1A. Alright, so we're in DC mode over here. And we can measure. So our ground should be the center pin over there. And then I should have the voltages around. Looks like I'm not getting any readings. Oh, maybe because I need to turn on the switch. So we have our 5 volts. We have our minus 12. We have positive 12. Positive 15. And negative 15. So everything is working good. Hi Steve, yes, camera is back in order. Was pulled out the USB from it. I don't know what happened. I really don't know what happened yesterday evening. So you just join now. In this case, let me show you what I done so far, because I didn't see that you joined it before. You just joined it right now, right? So here we go. I have everything here connected. The switch is connected. Everything is there. I have the fuse connected, everything. And let's measure some voltages to show how it's working. So switch on. The center pin should be the ground. So I'm gonna put my black probe over there, and I'm gonna start from the number 1. So here we should have the minus 15. So there is minus 15. Then I should have the number 2 pin positive 15. So we have positive 15. Then I should have positive 12. So positive 12 is there. And then I have negative 12. Negative 12 is there. And the 5 volts. So the 5 volts is also present over there. Hi JFX, you come also? You join it? I already soldered, so you missed that part. So everything is working perfect. I just installed it for now 1 amp fuse. I need to connect to the preamplifier and to see exactly how many amps is drawing to understand the right fuse to install it. So let me do that one also now to understand exactly the fuse that I need to install over there. So let me make a space on the table. And we're gonna see how we're gonna calculate the right fuse for this device. So let's get these probes aside over there. Let me bring the preamplifier over here. Maybe I need also to zoom a bit out. Alright, so let me open also this one to double check perfectly to make sure that the voltages on the connectors are on the right place, because I draw it on that paper which I saw it last night, but I want to make sure again that everything corresponds also how is connected everything inside the preamplifier. So what everyone is doing so far, which projects you are working on? Oh, what are you repairing? Yeah, camera is working nicely today because I already fixed it. So as I say, I have the pin number 1, which it was -15. So is that blue that goes to -15? Yeah. Then it was the red one, which is +15, which is going correctly where it needs to go. Then it was +12, which is this red over there, so +12 is correct. Then was negative red, which is the green one, and then it was the 5 volts, which is the 5 volts. Right, so everything working good so far. So ready guys for a smoke test, because I connected to the preamplifier. So everybody ready for a smoke test? Let's see if it's coming smoke out or I done everything how should. So what do people say? So Steve Zorilov says that has some Ramsa power amps and Hypercon, dimmer and Fostex speakers to fix. Oh, Fostex speakers are really good ones. And QSC's power light 1.0 to fix. And yeah, the speaker Fostex are really good ones. So my whole project looks really clean because I really like to work really nice. So I can see here zip ties to all the wire to stay in a right position and right place. You can see the transformer, you can see the PCB board, you can see the PCB boards, the wires going nicely on the sides or between boards, so it's not a mess like some other things that I open and all the wire goes everywhere here. So Magic Smoke, so you're ready? Like 3, 2, 1. I plugged, and now 3, 2, 1, I power. And the Magic Smoke didn't come out, and you can see here everything is working fine. I just need to connect my headset, so let me get my headset to connect them. So let's connect the headsets. Looks like it's working, but it's working only one channel. Oh, I have problem with these ones. I have another one in case of something. Let me change that one. Maybe that one has a problem. Yeah. This one is defected, but this one new one working perfectly. So that's the radio. I don't have connected the antenna, so let me do something. There is a channel over here.
90. And it says 5 points if you hear the retro game sound effect.
But let me just connect with the Bluetooth. And let's see if it's working the Bluetooth. So it's connected. You can see they're active. And let's play something from my YouTube channel to don't get any copyright strike. Hi guys, and welcome back to another video on my channel, and this time I will gonna do an unboxing and reviewing a bit this portable soldering. So everything working good. Let me go a bit through the chart again. So the box looks really nice. I really like it. Alright, so everything is working good, so I'm gonna show you how I'm going to measure the exactly value of the fuse that I need to insert it there. So I need to switch off for now everything, because I need to unplug, and I need to get some multimeter probes which are hiding in some drawers around here. Just give me a second, guys, to get them. Are they here? No, in the other box. Let me get the other box. Because I keep all my leads in different boxes like that is I feel more organized. So let me get the other box, because the leads I need are in the other box. Yeah, are here. So I need these leads, these probe leads over here. Now the boxes, they can go back to them places. And because I don't want to connect the multimeter which is connected to the computer, it is going to show you on the screen, I need to use a separate one, because I want to isolate, because if anything goes wrong, I don't want to burn computer or burn everything around here. So give me a second to get another multimeter to be isolated. Alright, so we are going to use this multimeter, the Unity, and everything what I need to use is to put on amps, is to connect the common and amps over here. I'm gonna put it here like that, you can see it as well. I say I'm using this one because I don't want to connect to the mains, because I need to work on mains, so I don't want to connect. I want to be isolated, because if my everything goes wrong, imagine I can burn everything, computer, everything what is connected through the computer to the via USBs. I can burn everything around here. I can burn the microscope, camera, everything what is connected to the USB, if there is any mains leaked to the USB. So I don't want to take that risk. So I'm doing like that with this multimeter. Alright, so your whole, what is else in the chat over here? Yeah, JFix say good to be safe. Yeah, good to be safe. So that's why I am plugged already. The plug is here, because I need to measure the mains to understand exactly the right fuse to put in. So I need also to get this one out from here, because I need to connect my probes to these two leads over there. So don't try it if you don't know what I'm doing. Okay, so here I need to measure AC. So let me have a look how I'm going to AC. This one is the range. Select AC. Yeah, so we are selecting AC and we are measuring amps. So AC amps over there. Let's connect the probes over there. See, it's unplugged. So like I say, don't do this one if you are not sure what you are doing, because it's quite dangerous things to do that, what I'm doing right now. Alright, so the probes, they can stay there, so make sure I'm not touching nothing in that side. Let's plug back. Let's power on. Is everything on? So let's play at max. and once it's playing at max, I can read exactly the total amount of amps that is drawing. So here it says that it's drawing only 0.065. So let me go to the range on milliamps. So in milliamps it says that is reading 66 milliamps, what is a total of consumption. Let's switch off to make sure that is correctly. So yeah, I switch it off, see it goes to 0. Turn it on. So that's and the volume is at max. So I have 66 milliamps, around 67 when it's at max. USB-C in this side and USB-C in this side. Really nice connectors. Now it's at max, so 67.1. Have in this box. On this box we have a small. So if it's drawing only 67.1, I'm gonna definitely use one of 100 milliamps. So I need now to dig on my fuses over here to find a 100 milliamps fuse if I have. If no, I'm gonna put the lower one what I have around here. So I unplug it, so it's safe to touch those wire over there. We can get this multimeter out of here and we go to find the fuse around 100 milliamps. All right. What else we have here on chat? So I had the guy here that helping me to read. I can't read. I could go under the microscope, but just to check a fuse under the microscope, I don't know if it's worst. So this one is say F2. So this is the 2 amp fuse. Let's go down there. Let's see this and what it says. This says F6, so this is a 6 amp fuse. Let's have a look what we have in this here. Let's have a look what is in here. So here we have F025, so this is 250 milliamps. So in case I don't find nothing less than that, I'm going to use that one definitely. Let's have a look here what we have. Ideally we want 100 milliamp fuse. So here we have F1, so this is 1 amp fuse. F025, this is same 250 milliamps. What about these ones here? This one says F05, so this 500 milliamps. Let's see in this row what I have. So I think those are the smallest one, 0 to 250. So this one is F6 amps, so that's 6 amp fuse. I think that's the smallest one I have, 250. So I'm gonna put the 250 milliamps now, and I'm gonna look to buy 100 milliamps. This is F6, so this is them 6 amp fuse. And here what we have, F5. So this is 5 amp fuse. So I think, yeah, this is the smallest one that I have in this set, the 250 milliamps. So I'm gonna use on one of that. So where is this one? What I put inside was 1 amp. So let me put it back. Yeah, it was F1. So F1, it was there. And that's the set of fuses I have here. And this one I just bought it new now. I bought it from eBay, not from AliExpress, and looks like this one doesn't work one channel. That's really weird. So let's put back the fuse and let's give another try to make sure everything is working with the new fuse before putting all the screws on them places. So this wire is gonna stay down there. Yeah, will not affect to nothing. So power back, power on, power on. And so we have working. BC2, BC3, B2, sorry, B2, the KR, and the K65. They're looking nice. Yeah, nice set of iron beads. Then we have the power supply over here, which is a 65 watts gun, which is really cool. It's the new generation of the power supplies. So yeah, everything working fine. Everything is working fine. And I need just to have a look for a fuse which is just 100 milliamps, because this is the smallest one that I have in stock. So I'm gonna use this one for now, and as soon as I get a chance I'm gonna get a 100 milliamps fuse. Now I can put all the screws back, and I think I'm gonna do a normal video because I need to film, I need to set up my oscilloscope, my dummy load, I need to see which amplifier to use it to do a test, to do some measurements on the oscilloscope to make sure it's working really nice. So on that I'm gonna do not a live stream, I'm gonna do a video recording because involve more things to do, and on a live stream it will gonna be not easy to do it. So I'm gonna do it on recording and I'm gonna publish a video. So Specs 360, hello, how are you? You just joined it now? You miss a big part if you just join it now. I almost did all the soldering, everything. This is not a radio, this is I'm building my own preamplifier with the amplifier headphone amplifier. So the preamplifier is based on Acophase C3850 or 3580. I'm not exactly now the number. So this is the preamplifier part, and here I have the headphone amplifier part, which drive the headset, the headphone, And here I have a mixer because I have a Bluetooth module which is sitting over here. So I have with this potentiometer I regulate the volume from the Bluetooth, and from the aux I'm regulating the volume on input over here on aux, and from the output I can drive amplifiers in the same times with this volume, and with this where is now market as a mic, because this one is a chassis that I reuse it from a different amplifier. Now I should label it headphone because this one drives the volume from the headphone over here. Yeah, about dummy load I was talking because now everything is working good, but I want also to do some measurements with the oscilloscope and to connect this preamplifier to an amplifier in order to do some measurements also with the oscilloscope, and for sure on the end of the amplifier, instead to connect to a speakers to have that beeping noise of a frequency, let's see 1 kilohertz frequency on the speaker, we're gonna be absorbed on a dummy load, and on the dummy load I can do measurements with the oscilloscope to see if it's a clean signal, if there is no spikes, if there is no distortions on the signal. But that one require lots of things to set, so I don't have yet, I can't do it on this stream, and I think I'm gonna do a normal recording video on that one, because I need to set up my oscilloscope, I need to set up lots of things to run few measurements, and then also to do a audio test recorded through the microphones to have an idea how is the quality sound of this device. So for now I just wanted to do the live stream finishing the power supply. So this one was the main thing for this stream, to finish this one. Oh, I was touching in him, but it was still plugged over there. So here, this is the power supply, which is bringing me to a 6-wire connector. The voltages I can measure like that, you can see the voltages. So have a look here. So this connector has the ground on the middle over there. So we have the ground, and then I should have here the minus 15. So you can see there on the multimeter is minus 15. Number 2 pin I should have positive 15. So I can see there is positive 15, 14.9. So you are over there. I should have now the next pin plus positive 12. So I can see there on the screen is 11.9. Here I should have negative. So you can see I have negative 12. And then the last pin I should have 5 volts, which drive the Bluetooth module. So you can see here we have also the 4.9, the 5 volts, which drive the module. So everything working fine. If you want, I can give another, anyway it's still here, I can give another test to hear that like that. Also the one that they join later, they can hear that everything is working nicely. So let me plug the headsets over here. Let's put the volume on minimum for now. Let me have everything connected over here. Yeah, this Bluetooth, by the way, also has also radio. But on radio I need to connect an antenna over here on this connector, and I don't have any prepared any connector now to have the antenna. But there is also close log. How are you? I hope you're doing well. So let's turn on to show you how it's doing. So I'm playing on my mobile one of my videos, the one that I did the review on that soldering iron from Kaiwitz, and I connect already the headsets. Yeah, we have a nice power supply. We have manual instructions, which I'm gonna read it later. and that's the sound that come off from it, from the headset. So when I say from these connectors over there, I can drive a powerful amplifier with the nice powerful speakers. But for now I don't have those ones set up over here around. So that's why I say the measurements and final test, sound test, and this one I'm gonna do a recorded video, because I need a lots of things to set up around. I need to put my good KEF, or maybe the TDL, or maybe the Missions speakers to set up with the microphones in the front of it, to do a recording through the, how it's called, Audacity software, or to do the recording of the audio bit, to have an idea how the quality of, how is the quality sound of this preamplifier. And then also when I do the measurements with the oscilloscope, I need to connect a dummy load, and it's not yet ready over here. It's some drawers, I need to find it out. And I need to get the probes on the multimeter, on the oscilloscope, to make it ready, to make it show display on my screen. So yeah, it's nothing ready for that one. I just set up for this video just to finish the power supply. And I'm sorry if you don't join it from the beginning to see when I solder all the wires for the switch, the on-off switch over there. I isolated with some heat shrink. Then I have I use that fuse holder because I don't have any other, and it was the discussion last night about maybe we're gonna melt because it's plastic, and sometimes, well, about the melt one, there is no heat in this one, and the total draw, I measure it, is just 67 milliamps. So I just need a fuse of 100 milliamps on that holder. So about heat is not any problem. Then someone commented, says that it's designed for those devices that work with 12 volts for cars. A fuse is a fuse, doesn't matter which voltages you are passing through. It's calibrated to a maximum current that can pass through, and if it's overcrossing the cars, just will gonna blow. So someone was saying, in terms of safety, when you open to change the fuse, you have those pins exposed and you can get a shock. But I'm thinking, who on earth tried to change a fuse with the cable plug it in? I don't know. Let me know in the chat, guys, if someone of you is changing a fuse with the device plug it in, because I never do. I never touch a fuse if the device is still plugged in on the mains. Let me know in the comments, guys, on the chat there. Let me adjust my camera because it's filming only where I want. I think I'm okay there. Yeah, let me know in the chat, guys, who is changing a fuse with the device already plugged in on the mains, because I never do. Okay, so this one I can put everything back, because this one is done. Now guys, tell me. I want to hear from you. If any one of you changing fuses with the device plugged it on the mains. So Clores looks say nice, get to see the amp your power supply connected to. Yeah, this is the device, and this one is also built by myself. everything. Only that I use a chassis which I bought it from eBay. It was an amplifier. And I buy this one like a spares or repairs because it was not working. And I did also a video when I also repaired the board. So yeah, if you go through my videos, you're gonna find also the video when I did the diagnosis of this board, what was inside, and I fixed it. But I took it out because, as I said, I bought it more for the chassis to build inside my own project. Yeah, it's made also this one. Do you want me to reopen again to have a better look everything inside? I have also lots of other videos. Yeah, let me open and I'm gonna explain. Let me open. It's just I put back only 3 screws, so I can reopen and I can also discuss about them. And if you want to watch the videos, because I made videos when I build the boards, when I put all the components, when I test them with the oscilloscope, how they working as well. So have a look here. So practically this board is all built by myself. All the wiring here is did by myself. This board also is built by myself with all these parts inside. Only what is also this board, the small board down there with these 2 potentiometers, is also made by myself. This one only I bought it as a module like that from AliExpress. I was more happy if I was finding one kit to solder by myself, but I couldn't find, so I find only a module complete. But these ones are all soldered by myself or calibrated and tested, because you can see this one has 2 trim ports here that you need to calibrate the right current to draw on no load, and then also to make sure on the output here you don't have any DC voltage, because this one needs to have only AC, because on the speakers or on the headphones is AC voltage that is coming, not DC. So that's why you need to calibrate here with some few resistor in order to have no voltage at all here on no signal input, because when you put the signal input, the audio here, we're gonna create on the output the AC voltage, because the speaker coil is moving back and forward from the AC. If it was only DC, we're gonna move only one direction, but that's why it's coming. So everything is powered by DC voltage, but is driving inside the AC voltage. So imagine how this circuit in audio work. That's why so other people they say they cannot understand too much in audio things, how things working. So I say you have a device that is powered with DC voltage, but actually inside of all the components is driving an AC voltages. Same on this one, is powered with DC, but inside the transistor is circulating a AC voltage. Something that it's not easy to understand it, right? How something, if it's powered on DC voltage, you should have positive and negative, right? No. Inside of this circuit is always circulating an AC voltage. So yeah, have a look. You can find the video when I build this. You can find the video when I build this and I tested with oscilloscopes. And I say, now I want to do also same a final test with all parts together, a test with oscilloscope and a test driving an amplifier with the nice speakers to see the quality sound of this one. Because on the headset that I tested now, I tested only with this my video, but I'm gonna have some nice audiophile music, and I'm gonna have some listening seasons before I'm gonna do the final video on testing everything. So can I close this one now back? So we have another comment there. It says on deep PV Ronnie, hi, how are you? Mains off on discharge caps, it's over 50 volts. Yeah, also there is dangerous, you know, on the power on the AC caps. Have a lots of danger also there. This is not a switch mode power supply, it's a linear one because it's a transformer, a toroidal that has the primary and then has 1, 2, 3 secondaries that give me all these voltages which I measured before. Cool. So with the setup you don't need a DC. Why is coming that one there? I cannot see. You need a DC blocker on power sockets to eliminate hum. You need a DC blocker. I know in audio there is some of them that they are using DC blocker, but actually it's all about how you do the grounding. In audio it's, you can see here I have this point over there, right? Let me just move a bit the cables. You can see that point? That is called the ground star. So the ground from the connector which is coming the power goes here, and from here is go the ground in this to this board, is go the ground to this board, is go ground to this board, is go ground to this board. So if I was doing, let's say I come with the ground from here to here, and then I come from ground to power this one, and from this one carry on the ground over here, then carry on the ground over here, you end up making a ground loop, and that ground loop it will gonna create a hum. But in this configuration there is no hum because you have just one point of ground where, because you know every single wire has a bit of resistance on it, right? So that's why the hum is getting created, because see the point from here to here I have a short cable, right? From here to here again I have a short cable that runs. From here to here I have a short cable that runs. Imagine if I was having, let's see, from here the coming ground here, and then coming ground here, coming down here. So from here up to here was creating a resistance, also few milliohms, but that one affect the audio, and it will gonna put in that hum. But in this way with the ground star you are quite eliminating. Anyway, you're gonna see when I'm gonna record the video, when I'm gonna do the testings, like I'm gonna do an audio test. I'm gonna set up a stereo microphones in the front of 2 speakers. I have good speaker, I have Missions, I have KEF, I have TDL, I have also some Pioneers, nice, and I can choose a pair of those speakers. I'm gonna set up my own Class A, my own design. It's actually also the schematic is designed by myself, a Class A audio amplifier, which really for me sound the most best of all of the other one I built so far. And I'm gonna do a recording bit of a brand, a sound, and I'm gonna use this software Audacity, something like that is called. So I'm gonna record, and then I'm gonna also do measurements with the oscilloscope to see the distortion on the signal. So yeah, I'm gonna do maybe next week or in the 2 weeks so far, like that. I'm gonna do a recording video, not a stream, a recording video, and I'm gonna do all the tests that I need to do on this one to show that with really cheap money you can achieve a sound quality of those amplifiers that costing also maybe 7,000, 20,000 pounds. I sell some amplifier. So where on earth you are spending that amount on an amplifier, 20,000, when also with a bit of knowledge you can build your own and make with more cheap something that sound same like an amplifier which costing 20,000 pounds. Can you show the software that I designed in the board? Yes, JFix, I'm gonna show in a minute. Let me just put the cover on this. Let me put the cover also on this one, because everything is alright. Only when I'm gonna order a 100 milliamps fuse, and when I'm gonna receive it, I'm gonna just reopen it and put inside the fuse, the right fuse, because now it's 250 milliamps. In case any short you do on this end of the cable, before that fuse blow, components here might can smoke. Understand? So if I put a fuse of 100 milliamps, as soon as I make a short over here, I protect also the parts, the components over here, they don't smoke, so it will gonna blow out straight away that fuse. But now how is this set up with 250 milliamp fuse? Before that fuse burn, something here can smoke. So to avoid something here to smoke, I need to reduce to 100 milliamps that fuse. But I don't have in stock, so I need to have a look for one and order. So JFix says that I saw that amplifier on Mendit Matrix channel was crazy money. Inside nothing special. Yeah, I told you there is some amplifier which there is one brand which is really so expensive, and I don't know why. How is called that amplifier? Let me remember. And they have amplifier that cost also £50,000. When I'm gonna show you the software, I'm gonna also look on Google that amplifier to remember exactly the name. But I say there is an amplifier which is costing also £50,000, and when you open them, inside is like nothing special, nothing to really say that you put the money on something that really has that value inside. But definitely I'm happy how this is working so far. For the little test that I had on my YouTube video which I played over there, definitely I'm gonna do some listening session, also connecting to the amplifier and driving the speakers to see how it sounds. But so far, this with this power supply next to it, it's really a cool combination, right? Well, so this one is packed. Let me put it back on its box. Alright. And now let's close this one, because also this one is finished, and I say I just need to reopen it when I get the fuse, because I don't have in stock. The smallest one I have is 250 milliamps. So this one should go over here. Looking cool. Looking all cool. As the power switch, these are the cable, and I put also this kind of how is called that, gorments, in order to don't have the cable by any chance cut by the aluminum around there. I could use connectors, but better to try to avoid too many loose connectors in the power cables, because you know, if it's a loose connector, it's not like a soldered with solder joint, you lose a bit of power on that connector. You see those videos that how is his name, Alex, I think is his name, Alex, the one that is repairing a lots of this RTX 490 video cards, and lots of video cards they have that 12 volts connector burn it out, because I say when it's a connector and it's not a tight solder joint, you lose a lot of power, and when you lose power, what happens? It's heating up. Where you lose power, it's starting to heating up things. So that's why he had all those video cards melted. Norted Fridge, no, yeah, that one, Norted Fridge, but his name is Alex, I believe, no? James. Your channel is JFix, but your name is James, right? So the same also for me. His channel is called Norted Fix, or how is to spell it, to pronounce this, Northridge Fix. But his name is Alex, I believe. That's what I remember. If no, please correct me, guys. But I know that his name is Alex. Yeah, that one. I say, see, we have a lot of video cards that he's repairing, especially the 4090s, no? With the connector melted, burn it, so that happened. So that's why I avoid to have another connector here and another connector on the preamplifier, because you lose power once here and you lose power again once on the end of this connector. So I wanted to avoid that thing. Right, so this is done also. Let me just clean a bit my table, and then we're gonna go a bit to the software that I'm using to design schematics and design PCBs. Just let me put all the stuff in the right place. So that goes there. The power supply, we're gonna go under the desk over here for now, because it will gonna be soon needed for that test and setting up. And after that, to set up some place on my back there, I have a cabinet where I have my audio thing to set up everything there, ready to listen into it anytime I would like. Let me put back on drawers the thing. So the multimeter, I use it to measure the current to be isolated. Let's put it back to his place on the drawer there. Right, that's in the right place. Then one deep FPV. Ronnie. Okay guys, so let me, how do I say, because I like all the time to be organized, so I need to put back the probes in each box. It's a really nice, cool way how to organize your things. I don't know. Let me know, guys, if you prefer like that, or you prefer just hanging around the cables. You know, I like to hold them all the time on boxes, and when I need, I know where is the cable. I come and I collect the cable that I need, and I put the box back in the drawer. That's my way to keep my things. What about you guys? How are you organizing your things? zip ties, they can go back to the drawer the way belong. So here I have a set of tweezers. I have from the biggest to small to very fine ones like these ones, very fine ones. Have a look on this one how they are. If my camera wants to focus. Alright, so have a look on this one, how tiny and how fine they are. And then I have a big one. Comparison between those one and these ones. It's a big one, huh? Big comparison. Yeah, I have a nice set here. So I have straight, the finest one. Then I have a little bit bigger. Then I have a little bit bigger, same straight. This one has also nice teeth over there to grip better when you want to desolder. This one, let me see. They have also teeth there that you can grip the component much better with those teeth over there. I can see. So I have this one. Then I have another, the blue one. I think these ones also James. They have a model like that, a mechanic one like that. Focus on it. A mechanic tweezer like that also James have, I saw. Then I have a fine bent one, this blue like that. I focus a bit. So I have these ones that bend and fine. Then I have this model which I recommended also to James. This type of model because this one is good for especially for KFN or BGA chips when you need to resolder it, because you hold it on this place, right? Flat with the PCB, and you can hit. You have all the heating up from the top and it doesn't bother. Imagine if you have the tweezer that you need to hold like that and the heat. But this one, see, you can hold the chip from a side. So I recommend it to James to get one pair of this one because they are really handy. And then I have a big bent and a big straight. And then I have a plastic cork bar and pointer and another one that you can open easy the connectors from motherboards with these ones. So yeah, I have this set that I keep organized in here. So Carter say he liked my tweezers, okay. Then Ronnie says that also he got lots of sorted tweezers recently. Yeah, you need tweezers, are really helpful. Without these tweezers you can't do a job like that. You really need them. And Crosslook says, for organizing my tools, my work was getting rid of bunch of plastic micrometer boxes. I grabbed all of them and store my stuff in them. It's a good to don't spend money on boxes, because also me, I really want to use whatever I have. Like this one, I had it from something else and I just using for my tweezers. This set comes like that. This test of screwdriver, which I really like. It's really strong metal. This one is not. I had so many other tweezers, screwdrivers, but this one is a strong one. Look also the sound. It sounds like it's something strong. See, they are really strong material. It's not like those on cheap that you undo two screws and that's it. All the tip there is no more a tip. Yeah, also that is a good. If you have a 3D printer, you can design properly your own size and your perfect size that you need for what you want to storage in. This is the caliper. That's also always I need it. I can also go through which other tools I have around here because I have a bunch of other tools. So I have another thing over here. Here I have some this one extractor pump for the soldering. Here I have some ceramic tweezers. These 3 is a set. I have another 2 bend big ones. I have one ESD 15 over here. I have a wire stripper on this one. I have this one to open devices. I have a tiny screwdriver, a plastic pointer over there, and also these things to open devices. How you call it these ones? And also a set of small screwdrivers over here that the smallest brother is here. Now they are all together. Yeah, I have also this set of thingy over here. And I have another special tweezer to show you guys. This one is a special one because special for BGA chips. Because have a look how it's down there. As a bend that it will gonna grab the BGA chip properly underneath, and it will gonna you're gonna lift it just straight away like that. You avoid messing up with the balls of solder. And if you are doing the right job, sometimes you can resolder back a BGA without reballing it. So this one helped a lot for that job. Yes, Spadger, sorry, I don't have exactly that name on my head now. Spadgers, to open things. Yeah, I have also this special tweezer over here that always stay in his own box. Yeah, guitar picks, yeah, you can also sing with those one, I know, guitar picks. You can put shanks in impact drill. About what you was talking, James? I can put shanks on impact drill. About these ones? Yeah, I think it's the same size. You can use it also to hand drill machine. These ones. Yeah, has the same size over here. That can fit on that kind of the hand drill machine. Oh, what else I have down there? I have also a special one to clean PCBs when you work on it. I have lots of things around here. And this one, they always stay in them boxes because they're special things for me. Alright. This is almost everything what I have in that drawer, apart of the multimeter which I use it and I show you. This is almost everything. So let me put in the right order inside. Tweezers down there. The chopper and the players goes in the same drawers over there. And that's done. This one is the drawer, next one over here. And the fuses, they go up there. And this one also in a drawer up here. And now what I have to do is to show you the software, what I say, right? So let's switch to my computer, but let me first open my internet page to show that. So let me prepare everything in a minute. So maybe for now I can put the front camera like that, and until I prepare everything here to show you my my software I use it to design this project. Let me to prepare it because I was not on here ready to show you that one. So where you are, my thingy over here. Okay, so I'm there. I need to log in on. So let me log in and to show you. I'm almost there, so let me find it because I have lots of projects here. So let me find the right one. So preamplifier power supply, I think is this one. Yeah. All right, so we are there. So let me just bring this page on my OBS. So it should be here. So it should be this one. Yes, we are there, right? Oh, let me go a bit through the chat again. So I go lost to buy. Right, so here we go. This is the software which I use it. So I can see here is the schematic. So it's very simple with some voltage regulator, the 12 volts positive and 12 volts negative, the L7912. So come the AC voltage, and I have two bridge rectifiers, capacitor to smooth them down, the voltage regulator to make the voltage stable, and then smoothing again the voltage. Same also for the 15 volts. I can see I have a positive one, the L7815 over here, and I have the negative L7915. Same also here, you come with the IC voltage, bridge rectifiers, they are smoothing and converting to DC. Then you have the smoothing capacitor, regulator, again smoothing capacitor and output, and this one is for the 5 volts. And here is only one regulator, see only the positive one, the 7805, because I don't need a negative voltage over here, only positive. And you can see here, this is the ground, no? And here, see, the ground is pin number 2, and then you have another voltage under the ground, so this is a negative. So you have positive on pin number 2, it will gonna be a positive respecting with the pin number 3, but then on pin number 2 it will gonna be pin number 1 positive respected to it. So imagine how this thing's working over here. And here I have lots of other projects which I designed. So this one, I think it was, let me open this one. Yeah, this one was the project when I try to make sure that I am matching the SMD components with the footprint. And this one should be the PCB. See, this one has a footprint PCB, the SMD components. So when I designed this one, I designed just a quick one, just a trial, to make sure I am matching the footprint of the parts that I have around with the designing the PCB. yeah, this is the thingy, and I was call it that I say that I want to show you also that how is call it that amplifier which costing really almost £50,000. So I think I have on my AliExpress a copy. Let me go to my AliExpress. think I have a copy of a PCB board. So because I always not remember the name of that one. I remember now. So let's open another page and go there. Dartzell. Yeah, these ones are. These ones. There is some amplifier which are costing a lots of money. So if you go there for shopping, have a look. This one here, £55,000. Imagine who is spending all that money for an audio amplifier? Huh? Who is gonna spend that money for an audio amplifier? £55,000, man. That's crazy, right? So yeah, that's the one. And if you're here, let me also show you, because I was thinking for something, because I want to try lots of different fluxes to see how is working, and in which particular job you can use them. So I have a selection of all this. I just need to go and order them. You can see here lots of fluxes, which I'm going to order them, and I'm gonna do a video, compare them, but compare them in that way, that because I believe every single kind of flux is made special for a specific job, not for you can use all the things on all the type of flux for all, let's see, or for desoldering you can use one type of flux and it will gonna help you. For soldering, maybe you need a different flux in order to offer you that surface tensions to keep the component in place, in order to don't blow it up when you use the hot air station on it. So yeah, so that's why I want to try to order all these kind of fluxes and do a video on see how they perform and which jobs they can be used better. Well, so I think this is all for tonight, guys. I don't have nothing else. Oh, my camera doesn't want. I don't think I have no other things to do tonight. And thanks a lot for joining me. Yeah, I saw NanoFix just posted a video about fluxes, but not the right way. It's okay, it's nice video what he did, but it's not the right way, because I say every single type of flux is made for a specific job, because some of the fluxes give you more that tension. You know, when you put the component on the PCB and you blow the air on the top, will not blow the component away, so it's giving you the surface tension better. Some of the fluxes you just needed to make that to make the pins a bit oily when you need just to desolder a component. You don't need a super flux in order to do a desoldering. So that's why there is in my opinion different fluxes for different jobs. I don't know, what do you think about, guys, about that? What do you think? It will gonna be good to make a video to classify the fluxes for which jobs are better to use. So if you are doing only soldering, because also there is a special flux to use when you do the reballing BGA. You can not use any type of flux over there. You need to have another specific type of flux over there when you do the reballing chips. That's my opinion. I don't know. Correct me if I'm wrong. I don't know. Because no one in this world is perfect to know everything. So what else we can do? Nothing tonight, so I was gonna say thank you so much for joining me, and I'm gonna say here is almost 11 o'clock, so maybe it's time also to go sleep as well. So James says flux seems to have very different color and textures. Yeah, and I can say that has also lots of different of how to say characteristics. So one flux, as I say, can give you more of the surface tension. Other flux can give you more oily thingy when you do special for reballing. I understand that you need to have a flux that is more oily, because not to be sticky. Because when you use the stencil on the top of the chip, if it's a bit sticky, that flux, when you remove the stencil, you can also pull up all the balls that you put them on the right place. So there is a special flux that you need to use in order that you will not have that. It will not happen that one when you put the balls, and then when you remove the stencil, if you use a sticky flux, you're gonna take out also all the balls with the stencil out. Yeah, no camera issues this time, because see, still working. No camera issues because I say the only things what happened. I'm pretty sure when I moved that cabinet there, it's touch the USB connector and make attention on the cable, because I had the box there, cabinet is here, and the USB was here plugged. So when I push the cabinet, definitely push on the USB, and for sure if try to pull it out, and that one happened last night. But now I fixed everything, and I also add your extension that you sent me, James, and now the box is just underneath of behind of the monitor, and it's easy for me to reach at any time if might happen any problem now. I wanted to show you something, so let me zoom out. Maybe some of you, which one are using trinocular microscope, we're gonna be handy these things what I want to show you, because I noticed that I get 3 times a better quality than before. So here we go. I want to show you this. So here the bracket which hold the head mounting, no? The head mounting, this how you call it, that you can lift it up and scroll down, used to be a straight one, and I'm gonna show you in a minute on the internet which bracket I get it and I install it here, in order that now my microscope is not sitting properly in 90 degrees on the table. It's sitting a bit in an angle like that, and all the reflection of the lights doesn't come at all back to the to the lenses, and I'm getting a better image. And if someone is interested, I really recommend that you can get that kind of with this handle here. I can tilt it and I can put in any angle I want. See, if I will not do it now because I need then again to correct it. But anyway, if I lose this bracket over here, my head, the head of the microscope, I can tilt it how I want. I can put it respected with the table, the surface working, in which angle I can put it like that or straight, or yeah, I really like that option, and really it give a better quality on seeing things on the PCB, because you don't have the reflection of the light back on the lenses. So if anyone interested, I'm gonna show you now on internet about this bracket, which one I'm talking about. So let me go back to the internet page. And I'm gonna show you quick about that one. So let me close this one. So I got it from AliExpress. Let me go to my orders. And let me show you which one I'm talking about. This bracket, yeah, this one. So I get it just simple like that. And taking into consideration they have two models. They have the shorter one or longer one, and this one has the 25 millimeter. You can see here 25 millimeter diameter of that tubes over there, or you can go with the one that is thicker, is 32. In my microscope is the 32, so I needed to get this one. So I get this one, and here at the end you can 3D print a part of things to put inside, and then you can adapt it to your mounting side of your arm bracket. And see, with this one, with that handle there, you lose, and you can tilt this holder in which angle you want, and it's giving you really a better quality when you look on the PCB. So Ronnie says that he don't know how to get the solder ball sizes correctly. Is there a way to measure parts to find out? Is there a way to measure parts? Yeah, but they are very tiny, so I think you need not a caliper. There is, I think, some micrometers are called there. I call it those one. I remember that it's something that you spin so much, and then slowly you move the thing that is measuring. So I remember that was called like micrometer. But usually the solder size, the solder ball size, you need to get them in accordance with the stencils that you are using. That's why I want, I think from the Xbox 360, I'm gonna tear it down apart, and I'm gonna try to practice, and maybe I can do some videos in reballing BGAs, because I have a kit, and I have also a kit of different size of balls, and maybe together like that we can learn directly for which kind of size of stencil we can use, which type of balls, because on the stencils it's telling you the size of the pads. So I think there you have the stencil that is already telling you the size of the pads, and in accordance with that one you can use the right balls in order for the stencil size. So course look says nice. Is that built into your scope or the arm? So as I say, it's just 3D printed part over there where you are this picture. I 3D printed part over there at the end of this one, and I use a bolt, I think a M8 bolt. That let me put back to the camera to show you a bit, to have an idea like how I did it to adapt it, because I buy it randomly. I don't buy it that something that comes special for my thing. So you see on the internet picture there at the end, the end where you need to mount it. This one make to don't focus. Yeah, see the phone make to don't focus because reflection. So let me bring it again here. So here at the bottom, I can show you like that. I don't have a camera to point from this side, but I think you have an idea. So here at the bottom, I have a bolt that goes through my arm, the moving arm, because this is the moving arm now. Articulated arm is from 2 pieces. And here I have a bolt that goes from down, I think is an M8, I believe. And I have in the top that 3D printed part that goes, screw it on the bracket, and from the bracket, once it's holded there, with this one I can lose it and move it left to right how I want. And then, as I say, I'm gonna move it and I'm gonna rearrange it again in another day. So you see, now if I move this, if I lose this one, in which side? Which side is losing? Left or right? See? Now I can tilt. I can tilt my trinocular how I want, in which angle I want, and I can tighten it back. See? Now I leave it a bit more down, so that's still gonna be too much for me. So I need to bring it back up. So I think I set up in a size of something like that, and you tighten it, and that's it. And you, instead of having 90 degrees that all the lights from your ring light come properly back on the lens, the lights goes now like that and reflected. You know, the light is reflecting always 90 degrees. So if you go in a mirror from a side, you're gonna see that the lights goes in a mirror and the beam goes like that. So imagine if you point like that, the lights goes to the mirror and come back straight, because it will gonna do always a 90 degrees, the light reflection. Yeah, you need to measure your in order to understand, to order the 24 millimeter or 32, you need to measure this part here, this diameter of the hole here. So the one that I have supporting mine one here is 32, so I needed to order 32, this bracket. That's why you need to measure and make sure which size is fitting on in your one, and then you order the one that fits in there. But I say, is a game changer, tilting a bit the lenses to don't stay properly straight at 90 degrees on the table, to be a bit just, let's see, instead of 50 to move it at 45. Only that 5 degrees tilted help you a lot to change a lot of image. Maybe I can show you a bit playing with the angle. So let me just swap to my microscope, and just you're gonna have it a quick look to see how it's going while we are here chatting about this. So let me get a random board over there. So see how is the quality of now, because it's not a 50 degrees down, so I have an angle, and see the quality how you read. So now let me playing with the degree on this one. So let me put it properly straight now to see the difference. Okay, so now I go back to exactly 90 degrees. Okay, so now I'm in 90 degrees perfectly, and I need to adjust a bit the see now how much reflection you get back on the objective. You can't understand. See all that flux that I played around with this guy. This is a practice board, soldering, desoldering. I desoldered and I resoldered this one. Desoldered with the hot air, soldered back with the hot air, desoldered with hot air, soldered back with the soldering station with the iron, not with the hot air. Same I did also with this chip. So that's why it's so much patchy around with the fluxes. But look, the difference when it's 90 degrees, so this is properly 90 degree, and now it just tilt a bit. You see all this reflection, special here, see? Lots of reflection coming back. Special here, look, where it was flux. Have a look how all the shiny come back and you can't understand very good. So now I'm gonna tilt it back. And now let me focus back. And see now? It was a lot of flux over there. There is no more reflection of that shiny back to the microscope. And now you can see more clear everything on the board. Have a look there. There's not anymore all that reflection. Especially if you want to inspect pins, you can see them more clearly now. There is no reflection, that shiny coming back. And also reading of the chips. You can see it better on this position. What do you think, guys? So Ronnie says that yeah, about the stencil. I know that some stencil is saying the size of the pads. So accordance with that one, you're gonna use the right size balls. Definitely. I'm gonna try to do say. I think I'm gonna use that Xbox 360 that I get from my friend from this cash converter. Because definitely there is BGA chips inside. Just to tear it down, take off the BGA chips, and try to make some maybe a live stream on how to do a better reballing chip. I think is a good idea. Yeah, working nice. As I say, I find it an idea, and just tilting like that, all that reflection of flux and shiny things back on the camera doesn't come back. So I'm really happy with these things, just to have the microscope tilted a bit, and it's giving me more clear to see things. You can see it also in the screen. Also, if I need to zoom out or zoom more in, and let me just make sure I'm focused on the pin. Look how clear I can see the pins, if there is bridges on them, or if everything correctly in those pins. See, if I focus, you can see really clear that there is no shining back to understand if there is any bridge between the pins or it's something wrong over there. Yeah, I really like this idea to have it a bit tilted, not exactly in 90 degrees. Okay, have a good night, JFix. And I'm gonna say also, let's finish here, because I say whatever I needed to do, I finish it, to finish the power supply. That was my main things to make sure that is finished. And while we was here, I just show you a bit of tips I'm using here in order to get better quality, especially with the microscope. and also the software I'm using to design PCBs and schematics. And I'm gonna say until the next one, have a good night, guys, and see you soon. Bye bye.